This is group 30, and then we are supposed to find the root locus of the unity feedback system, given the function g of s is equal to k into bracket s plus 1 all over s into bracket s minus 1, where h of s is equal to 1.
This is the transfer function g of s, which is k into bracket s plus 1 and then all over s into bracket s minus 1, and then h of s of 1, h of s equal to 1. So first of all, solve for the poles, and then the poles is the zeros of the denominator. So when you solve it, you get s equals 0 and then s minus 1 equals 0, which is s equals 1. And then we have two of them values, so n equals 2 as the two values. And then for the zeros is the zeros of the numerator, which is s plus 1 equals 0. So we get s3 equals negative 1 after solving s plus 1 equals 0. And then we have just one of the values, so that's n equals 1. So solve for the number of branches, which is this formula, n equals max nm, which is 2. Now if we solve for the asymptotes, the asymptotes is the number of poles minus number of zeros, which is n minus m, which is 2 minus 1, which is equal to what? 1.
To find our breakaway points, we first consider our characteristic equation, which is this. And by making k the subjects, we get this. Then we find the derivative of k with respect to s. We get the quadratic equation s squared plus 2s minus 1 is equal to 0. And solving the quadratic equation, we get two critical points, 0.414 and negative 2.414.
Let's take a look at the movement on the S-plane. We start with our two opening poles, one at the origin and one sitting at positive 1. Because the pole at positive 1 is in the right half plane, our system starts off unstable. Now as we increase the gain k, these poles move toward each other along the real axis. They collide at exactly 0.414, and that is our breakaway point. This is the moment they leave the real axis and become complex conjugates. Now let's notice the path they follow. As we prove mathematically, they move in a perfect circle centered at 0 at negative 1 with a radius of square root of 2. Now the branches curve back around and land at our breaking point, that is negative 2.414. They are now safely in the stable left half plane. And that's the complex root locus for this system.